Watching the manufacturing process of giant military gun barrels
finally helped me understand
why it takes the US for months to make just one tube. Howitzers are the heart of the army,
and were once shrouded in absolute mystery.
Even the rifling was ground by hand on specific points
To make sure it passed high-precision 3D scanning.
and met the most elite standards,
Zero tolerance for error to avoid barrel explosions.
so the enemy takes a fatal hit, while the gun can still be safely withdrawn.
Since 1889, the Waterfly Arsenal
Has been making gun barrels in upstate New York.
By the time World War II began, over 100 dual-use facilities had popped up across the US.
In just one of these factories, 2,500 howitzers were being made each month.
FDR even issued a direct order, demanding that car and toy manufacturers immediately switch to making shells.
And even planes.
Even tiny, unknown dishwasher factories started making bomb casings.
Among all these factories,
One now famous company stood out big time,
and that was Ford. This pivot in direction,
helped launch them into the ranks of the global top 100.
reportedly, Ford built one aircraft every 63 minutes. By the end of the war, the US had made over 300,000 planes. Meanwhile, only 139 cars were made during the same time, but the scales of fate never stay tipped for long. After World War II ended,
In the following decades, the world entered a relatively peaceful era.
no longer driven by competition,
Naturally, the demand for weapons plummeted. So the Pentagon made a call.
to shut down hundreds of military facilities. But what they didn't expect was a new crisis brewing quietly.
On par with World War II, rising Cold War tensions sparked growing friction between the US and the USSR, so the Pentagon began outsourcing weapon design to private companies.
Which laid the foundation for today's well-known.
Military-industrial complex.
And when the Cold War finally ended, the defense budget also dropped proportionally, especially during smaller-scale conflicts like the Vietnam War. More and more companies couldn't stay afloat,
And eventually opted to merge or restructure. That's how we got today's giants like Lockheed Martin, Boeing,
General Dynamics,
Raytheon, and Northrop Grumman. The first four you've probably heard of, but Northrop Grumman, the fifth one, they're actually the third largest defense contractor in the world.
famous bombers like the Beta Spirit.
And global surveillance drones?
Yeah, that's them. I'd call them a true driver of modern warfare. The gear made by these 5 military-industrial titans
Has spread to every corner of the globe.
tank graveyards,
Aircraft graveyards. That's how people today refer to the US's massive stockpiles of military gear.
It's not that the equipment is unusable when war breaks out.
They just need a bit of maintenance to be combat ready.
There's a saying that fits. A dying camel is still bigger than a horse. So now, let's follow the camera
And see for ourselves.
how the US takes for months to make a single gun barrel,
It starts with an alloy steel,
containing carbon, manganese, silicon, phosphorus, and sulfur. Then it's placed into an electric furnace and heated to a steady 1-8 C.
unlike traditional methods.
Seamless steel pipes use a ring design. After loading the steel billets at the inlet,
An internal turntable rotates evenly and in sync.
once it makes a full turn,
The temperature hits the sweet spot 130 C, perfect for pressing. Gun barrels and rifle chambers have one thing in common. They're almost always made of seamless tubes.
even the tiniest gap on the bore or edge is unacceptable.
So instead of welding or rolling,
A different method, extrusion and piercing, is used.
basically, harder metal is spiraled into the core.
So the outer pipe wraps the inner one, like a sausage within a sausage. Sometimes you even see it glowing and changing color. Not sure if that's just a white balance issue on the camera, or actual iron oxide forming. The oxidation you see is caused by high pressure reactions inside the tube wall. Next, the raw barrel blank is reloaded.
Now slightly slimmer than the original billet. It's solid steel, because the initial forged tube is uneven, to ensure both inside and outside meet precise specs.
The inner space is filled completely.
This prevents any offset during the next round of hot pressing.
And now, take a close look. Once the inner wall is packed tightly, we just need to roll from the outside inward,
Then we insert solid steel.
so it adheres closely to the inner wall.
As long as the steel quality inside is solid.
It doesn't matter if the hot rolling is fast or slow. It won't affect the shape of the seamless tube.
Now let's check out the surface.
Looks way smoother and rounder than before, right? But looks aren't enough, we need real proof. So the tube is rolled forward and scanned with infrared sensors.
Only when the entire seamless tube
From start to finish,
stays within strict tolerance limits can it move on to the tempering furnace.
remember extruded tubes carry a ton of internal stress. So,
A second round of heating is used to release it.
aside from this,
There's also something called the Mannesmann piercing process.
it uses angled rollers to pierce the center.
Then elongates the tube with a mandrel. The good part, it's fast. The downside, only suitable for low alloy steels. But if you're making gun barrels or large caliber rifle tubes from high strength steel, extrusion is clearly the better option.
At the same time, clean water is sprayed on the surface to cool things down quickly.
But rapid cooling always risks deformation. Still, that's not something the pipe plant needs to worry about. That job falls to the arms manufacturer.
With nearly a century of expertise shown in this video,
they use it to forge 155mm barrels. Once the steel is preheated to 2 OOC, it goes straight into the forging press.
This kind of forging is meant for solid or hollow shafts,
and is designed specifically to stretch metal lengthwise. It's more agile than traditional heavy tonnage presses.
So as we can see,
they got this done in under 2 months.
They managed to stretch it to more than 3 times its original length, according to the engineers, from the first hot press
to final deployment. The whole process takes for months.
We're not sure how long each step takes exactly,
but judging by how the tube looks, almost perfectly even all the way around,
it's clear this isn't something you can whip up in just 2 or 3 days. That's because the M777 Howitzer
has a max firing range of 15 miles.
Even the tiniest deviation
could cause a misfire or even a barrel burst.
So every bit of detail matters.
Slow and steady craftsmanship is absolutely essential. Forging can leave uneven edges on both sides,
so the excess material has to be completely trimmed off. Next comes ultra-precise cutting inside and out.
That's just one of many meticulous steps in the process.
Once the machine starts, someone has to monitor it the whole time. Even taking a bathroom break means handing over to someone else.
Cut too much or too little, both can trigger a catastrophic crack during firing.
Another key step,
barrel straightening.
Looks simple at first glance. Just press down according to the numbers, right?
But engineers say the reality is way more complex.
Apparently, you need 4 full years of hands-on experience to even qualify.
No experience? Then you'll have to shadow a master for 4 years.
And whether you're paid or not,
that's another story.
Meanwhile,
another team is polishing the rifling non-stop.
CNC machines often leave behind tiny burrs that are almost invisible to the naked eye.
So following the grooves, they polish down all the tiny peaks and valleys. Which brings us to another major challenge: precision.
In our minds,
artillery has always seemed big and crude.
But who would thought it involved such insanely fine inspection work?
After manually scanning the inner barrel,
a 3D scanner then checks the flat surface and rifling grooves. Even layers that are barely visible get examined.
Honestly, before seeing this process, I thought any country could manufacture these.
Just copy the blueprint, right? Even if you haven't cooked pork, you've at least seen a pig run, right? Sure, anyone can make a barrel, but the real test,
can it last even 2 weeks?
Without exploding, that's the real flex. At first glance, it's just a hollow steel tube,
but clever design lets it handle a 90-pound shell like it's nothing. And the secret behind it, it all comes down to a recoil buffer system embedded at the base of the shell.
Once it locks in properly,
you can pull the ignition cord beside it and unleash a blast as powerful as 50 grenades. That humble-looking metal junk.
Turns out it's packed with clever mechanics. First of all, it's a solid block of metal,
machined down into shape using CNC equipment.
No matter how tricky the grooves or angles, if the path is programmed, it'll get it done.
So let me show you
how you actually load and fire this thing. Step 1. Press down hard using the tool on the left side, while placing the shell into the chamber. There are 2 ways to do this, by the way.
1. Lift the ramrod up,
and let the shell slide into position.
The second method works better for 2 or more people.
Load the shell first,
then use a steel rod to shove it firmly into place. The number of people matters, so different methods fit different crew sizes. Now,
we're heading to the Field Artillery School
in Oklahoma. It's time for their annual live fire final exam.
And yes, they're using real shells. Their posture, fire commands, and safety protocols
will all be evaluated in full detail.
Especially how they hold the shell. Since this thing weighs a full 90 pounds,
drop it on your foot.
You're not walking that off anytime soon. To keep these cadets laser focused, instructors bar commands
louder than each other in competition.
The 155mm Howitzer is now the standard NATO artillery size, but the biggest active system in the world. That title belongs to Russia's self-propelled Pion Howitzer.
So where exactly does that put the US military today?